Good morning, everybody. TGIF Fossil Friday. Welcome back to Fossil Friday Chats. I'm Brittany Stoneberg, the Outreach and Communications Coordinator for the Western Science Center. With me, as always, is Gabe Santos.
Hello, happy Friday, everybody. Brittany stole my line, but that's okay.
I try. Sorry. I wanted to be the one. I wanted to be the one to say it this week. I never get to say it.
That's fine. It's the Western Science Center special week. I'll let it go this time.
And joining us today is paleontologist Dr. Talia Karim. Hi, how are you doing?
Good morning. I am doing well. How are you guys?
Pretty good, pretty good. Getting ready for a big showing tomorrow at the Western Science Center, right?
Yep. So the Western Science Center, where Max the Mastodon lives, is reopening tomorrow at 10 a.m. and we'll be hosting the Inland Empire Science Festival at the same time, where Gabe and the Alf Museum will be joining us. It will be a masked event, so bring your masks and bring your curiosity for science, because we are very excited to finally be opening again after 18 months.
So exciting.
Yay.
I can't wait to see everybody there. But also today, I'm very excited to learn all about arthropods. As you can see, I wore a shirt for the occasion. Yeah.
Yeah, see, these two have really pointed out the gap in my wardrobe, and that I do not currently have an arthropod themed shirt, and I will have to fix that immediately after the show and go on the internet and do some online shopping.
I think so.
Well, if you're not familiar with Dr. Karim, you will be after this talk. She serves as the Invertebrate Paleontology Collection Manager at the University of Colorado Museum of Natural History. Her research focuses on Ordovician trilobite faunas and issues related to collections digitization and curation. Karim was a co-author on the 2021 NASEM Biological Collections Report, is an active member of the Society for the Preservation of Natural History Collections, serves on the Biological Collections Network Steering Committee, and is co-chair of the iDigBio Paleontology Digitization Working Group. I apparently have a problem saying the word digitization, but that's really cool.
As you weren't aware, Dr. Karim is amazing and does a ton of stuff. So we're very, very honored to have Dr. Karim on the show today.
Awesome. Well, thank you for that amazing introduction. And I'm sorry, all the things I'm working on have like crazy long names and acronyms. But shall I go ahead and share my screen? Okay.
Go ahead and share your screen. And just a reminder to everybody, if you have questions, go ahead and put those in the chat, and we'll get to as many as possible at the end of her presentation.
Okay. Are you guys seeing this?
No. Not yet.
Not yet.
Hang on. Let me try again, because it told me that I was already sharing. But I will... Okay, how does that look?
There we go.
There we go.
Perfect.
All right. Well, thank you guys so much for having me today. I'm going to talk about arthropods and museum collections. So I've kind of worked on a lot of different group of arthropods. So I'll give a little overview on some of the work I've done and the work I've done in museum collections on arthropods. So what is an arthropod? So they are one of the most diverse groups of organisms on Earth. If you look up the estimates of the number of species, there's between 1.2 and 10 million species of arthropods, which is just mind-blowing. There's so many of them. And a lot of these are undescribed. They're new to science. We know they exist, but they have not been formally described in the scientific literature. So what makes up an arthropod is that they typically have an exoskeleton. So you can see here on this insect, an insect has an exoskeleton. They have paired jointed appendages. So you can see the legs on this insect and you can see that they're jointed. They have a segmented body. So in this case, a head, a thorax, an abdomen, and then they have bilateral symmetry. So what that means is you can see this line down the center of the insect is that they are mirror images of each other if you draw a line down the middle of the insect or the arthropod. So arthropods include a lot of different types of organisms. So things like insects, arachnids, so spiders, scorpions, myriapods, crustaceans, so crabs, lobsters, that sort of thing. And then trilobites, which is what I spent a lot of my research career on. And today I'm going to talk a little bit about trilobites and then some about insects, which are the two groups that I have worked on the most. Okay, so why arthropods and really why paleontology in general? So this is a picture of me. I was maybe 5 or 6, and this was one of my first fossil collecting trips. I grew up in Oklahoma, in Norman, where the University of Oklahoma is. And this is a picture of the old Stovall Museum. And when I was growing up, my mom just kept enrolling me in summer classes for everything from how to build rockets to let's go collect fossils. And I got really interested in paleontology at a very early age and geology. I had a mineral collection from the time I was probably 5 or 6. And was always collecting rocks and then started collecting fossils as well. And when it came time to go to college, I decided to stay at University of Oklahoma and become a geology major. OU has a really good geology program. And when I started at OU, the museum here was literally across the street from my dorm, my freshman dorm. And I found out they had a volunteer program to learn how to prep vertebrate fossils. And the reason they started this program was because they were building a new museum. So You can see here, this is the old museum, and then this is the brand new museum that was opening when I was an undergrad at OU, which is now the Sam Noble Museum. If any of you guys have been there, it's amazing. So I got my start prepping vertebrate fossils that were going to go into the new museum. And then halfway through my freshman year, somebody said, "Hey, I heard you liked invertebrates." And I was like, "Yeah, I really like invertebrates, but there's only vert paleo prep opportunities." And they were like, "Oh, well, OU just hired a new invertebrate curator, this guy, Steve Westrup, and he works on trilobites. And if you're interested in doing invertebrates, you should go talk to him." So I literally just went and found out where his office was and knocked on his door and was like, "Hey, I'm a freshman, can I work in your lab?" And so Steve put me to work unpacking his trilobite collection that he had brought with him. I can't remember if he came from Canada or New York, but wherever he came from previous job, he had brought a whole lot of collections with him, his research collections. And so I spent the summer between my freshman and sophomore year just unpacking collections and then doing a little bit of prep on trilobites, learning to prep trilobites. So transferring those skills I had learned from the vert paleo world to invertebrates. And that really started my research career in trilobites. So I ended up doing an honors thesis with Steve, which I'm going to talk a little bit about on these trilobites. They're called Homotelus bromidensis, and they're found in Oklahoma. And then I went on to do my graduate work in Newfoundland in Canada. So this is an amazing shot for all of us that are melting in the summer heat. This is either late July, early August in Newfoundland. And it was just cool and sea breeze and misty. And I'll show you some more about the collecting and the work I did there. So a little bit about what are trilobites. So trilobites are an extinct group of marine arthropods. So they lived in the oceans, and they can generally be divided into cephalon, thorax, pygidium, but the term trilobite actually comes from these sort of axial divisions of an axial lobe and then a left pleural lobe and a right pleural lobe. So these three lobes here is what the word trilobite actually comes from. But most people are probably more familiar with cephalon, thorax, and pygidium. So trilobites have those same characteristics of arthropods that I showed you guys earlier. So they have a calcium carbonate exoskeleton. So they have a hard exoskeleton. They have paired jointed appendages, and occasionally we get these amazing fossil preservation of the soft tissue of a trilobite. Usually we just get the hard exoskeleton. But sometimes, like this trilobite here that's been pyritized, you get the soft tissue and the legs preserved, which is amazing. And this is a really good blog post from the National Museum of Wales on these pyritized trilobites. They have a segmented body, which you can see all these segments, and then they have bilateral symmetry, just like that insect I showed you before. So if you draw a line down the middle, they're mirror images of each other. So looking at the geologic timescale, trilobites lived from about 521 million years ago to about 251 million years ago. So they were pretty much alive during most of the Paleozoic. The earliest trilobites are here in the Cambrian, and then they went extinct just before the end of the Permian. And there was a big extinction at the end of the Permian. Okay, so my research on trilobites, the first kind of project I did was looking more at behavior, which was kind of a cool way to get into working on trilobites. So I was looking at these assemblages, these mass mortality beds of a trilobite called Homotelus bromidensis. So you get these big slabs where it's just a single species of trilobite, and you get tons and tons and tons of them. And so the question we wanted to know is, do these represent in situ assemblages? So do they represent some kind of life behavior? So were these assemblages is this what they were doing in life and then they just got buried and it's preserving what they were doing in life? Or were they transported and are these assemblages due to being washed away by the current in the water. And then if they are in situ assemblages, can we interpret any behavior? So here's another one of these giant slabs. And I prepped all of these. I spent a lot of Friday nights by myself in the museum prep lab working on these as an undergrad. And so one of the things we did to interpret whether these were in situ or not was to look at direction. So if these had been washed away by, like if these assemblages were formed by like wave action or current action, you would expect them to be all aligned in a certain direction. And you can see here that they're all like randomly oriented. So we don't think that they were, these assemblages were produced by any like wave or current action. And then the other thing we wanted to look at was whether they were molts or carcasses. And the way we would do that, and it's kind of hard to tell in this picture, but trilobites molt like a lot of other arthropods. And you can tell whether these are molts or carcasses by whether the sutures are open or not. So another thing that we could look at to look at this in situ assemblage thing is to look at the geology. So this is a slab. So before we were basically looking at a surface on top of this layer here. So we cut through the rock and here's that same layer. And then here is just tons and tons of lime mudstone that hasn't been burrowed. It's just solid lime mudstone above this trilobite bed. So this is another indication that these things were rapidly buried just by a big mud dump and that they're representative of in situ life behavior. So it's kind of a cool way to combine geology with paleontology. And then interpreting behavior. So some of you guys may know about horseshoe crabs, and they do a very similar thing today where they come together for these mating events on the beach, and they'll just like a whole bunch of them will come together and then they'll go back in the ocean. So we wanted to kind of explore or like use that as sort of a modern analogy about why these trilobites maybe were coming together. So maybe they were coming together for reproduction or molting, similar to closely related arthropods that exhibit similar kinds of behavior today. And this is a good blog post from Nature if you're interested in reading more about this behavior in modern horseshoe crabs. Okay, so the other kind of, most of my trilobite research has been just straight up describing trilobites. There are tons and tons of new trilobites to describe. These are from a paper I published in 2008 from Newfoundland, from Canada. And you can see some here. So this trilobite, Leobinvelia terranovica, I assigned to a previously described species. So this is the author that described it originally and the date. Some of these were not well preserved enough to give them a formal name. So sometimes those just get left in what we call open nomenclature. So we can maybe assign it to a genus, but we don't know exactly what species it is, and we don't have enough of the organism preserved to say more than that. And then the fun part comes when we have enough of the animal preserved to describe it. So this one I got to describe, Bogaspis jordii, and you see my name gets to go after it and the year I described it. And the fun part is you get to name it after whatever you want, basically. And so I was really having a Star Trek moment at the time in 2008 and watching a lot of Next Generation. And so I thought this trilobite had an eye ridge. It's a little faint in this picture, but this trilobite has an eye ridge that reminded me of Geordi LaForge's visor from Star Trek TNG. So I got to name that species. So one of the cool things about arthropods is because there are so many undescribed species, there's lots of opportunities to name new species in the literature, which is pretty fun. And I've done a lot of collecting for trilobites. So in Newfoundland, where these specimens I just showed you were from, these are a really unique collecting situation. So you can see here, like, it just looks like these big, like massive debris flows, which is what they are. And what we're actually collecting is trilobites out of boulders in the debris flow. So it's not like the typical bedding planes you might see. And here's one boulder. This is my friend Lisa Amati. She's a paleontologist at the New York State Museum. And you can see this boulder is as big as Lisa. She's about 5'2", and then you get smaller boulders that are, the size of a rock hammer, and so you're actually looking for, which is crazy. I've also done more normal kind of collecting where you're collecting from bedding planes. This is in the Great Basin with our lab group at University of Iowa. And doing geology is always part of this, measuring sections and recording what the rocks look like and that sort of thing. So for me, the geology is a big part of the paleontology. So after I finished my PhD, I kind of transitioned into working more in collections management instead of doing research, like straight research. And I've been here at University of Colorado for about 11 years now. And these are just some example things from the invertebrate collection. So we have everything from shells. These are gastropods and bivalves. We have a really nice collection of invertebrates from the Western Interior Seaway from the Cretaceous, so lots of ammonites. And we also have a really big microfossil collection of foraminifera from the very end of the Cretaceous before that extinction, which is a really unique collection that we have here. But one of the really big things we have here is we have one of the largest fossil insect collections in the world. We have somewhere around 65,000, 70,000 fossil insects, and they're almost all from Colorado, which I think is super cool. They're mostly from the Green River Formation and then also from Florissant. And some of you guys may have been to the Florissant Fossil Beds National Monument, which is a national monument you can visit. It's outside of Colorado Springs, and it's super cool. And they have these giant petrified tree trunks, and then they have amazing fossil insects and plants. So we have collections from there. And when I got here, we were in the process of curating a very large donation from an amateur collector named David Coles. And he was collecting in the Green River Formation, and he had collected tens of thousands of fossil insects and donated them to University of Colorado Museum of Natural History. And as part of getting his collection curated, there was a funding project or funding program through the National Science Foundation to do these big collaborative digitization grants. And so the Fossil Insect Collaborative was funded, I believe, in 2013 or 2014. I can't remember the exact date now. And so we were able to database and image our collection of fossil insects on that project. And then all of our data generated by that grant project are available through the iDigBio portal. And so these are just some insects from and other arthropods from our collection. So there's this cool ant. This little guy in the middle is a spider. We have tons and tons of spiders. And then this is one of my favorites. This is part of a beetle, and you can see all the little hairs on the rear end of the beetle, which I just think is amazing. And these things are tiny, very tiny. So the kind of overall goals of the Fossil Insect Collaborative Digitization Project were to, there's some project goals and then some research goals. So the project goals were to database all the major fossil insect collections in North America, of which we were one of, and there were about 7 or 8 other institutions that were digitizing as well at the same time. So we were databasing them and then doing digital images. And so you can see there's a couple here from Berkeley, UCMP. They have a really nice collection of insects preserved in amber from Chiapas. And then they have some compression fossils like we have, and then here's some of our compression fossils. So it was kind of a mix of things. And then we would share all of our data with iDigBio and GBIF. So GBIF is and iDigBio are both kind of research portals. So if you're a scientific researcher, you might go there to look for information about specimens held in collections. And then we also developed the iDig Paleo Portal, which is more of an education and outreach site. And I'll show you what that looks like. And it's a really great way to interact with collections data if you're interested. And then this project also had some research goals. So once we created this massive data set of fossil insect data, you could use it to do things like look at how insects respond to climate change in the past. As temperatures are warming or cooling, do insects do certain things? Do they go extinct? Do they move? Like, what happens? And then also just purely evolutionary history of insects. It's really interesting to know how insect groups are related to each other. When did they originate? How did they evolve? That sort of thing. So we had a variety of researchers that are interested in these different questions using the data we produced. So one of the really fun things about museum work is we get to make these fun workflow diagrams. So this was our very complicated workflow for the fossil insect digitization. So these started with new field collections. We did some pre-digitization curation. You know, it ultimately leads to this digitized specimen record that's then served out to a variety of different audiences. And then there's all these different steps that are happening in between. So one of the things I really like about collections management is coming up with these kind of workflows and how do you interact with specimens and how do you create data and how do you serve it and how do you manage these projects. And I think that's really fun. So here's our sort of pre-digitization curation stage, what that looks like for this project. We had new collections that were, you know, literally just in boxes on top of cabinets that we had to unpack and put into trays. And we had a retired volunteer working for us. And I don't even know how many, like tens of thousands of insects she cataloged. She was amazing putting numbers on insects. And we wouldn't have been able to complete this project without her. So once they got numbers put on them, we could then image them. So this is what our imaging setup looks like. So we've got 2 monitors, we've got a bunch of light. These are our old lights, which we've since replaced. And then we've got a big copy stand with a microfocusing rail, which some of you guys might have used to do macro photography, and stacking images so that we can get the whole thing in focus. And it's really important for tiny things because it's hard to get really tiny things at really high magnification and focus. So we did a lot of imaging and then we did a lot of databasing. So once we had numbers on things, we could enter them into our collections database. And we had a lot of students and myself working on this project doing a lot of databasing. And honestly, that's a lot of collections management right now is data management and managing specimen records and managing images. So if you're interested in computer science at all, there is definitely a place for you in the world of museum collections and paleontology. So once we had everything databased, we could serve it out to a couple of different portals. So we have our own portal on the CU Museum website, and you can do some simple searches. You do need to know sort of some information to plug into the search fields to get some information back. But then we have this iDigPaleo portal, which I mentioned before, which is much easier to interact with our data. So if you go to idigpaleo.org and you click on the browse button, it will automatically just bring records back. Like you don't have to type anything in, you don't have to know anything about the group you want to look at. And then you can use these filters. These are all like expandable, clickable filters on the side to dig down and explore more things. So you can search by common name as well. So if you want to look at ants, you can click on common name and then find ants and it will bring back all the ants, for example. And then it will show you all the images, which is really cool. And right now on iDigPaleo, we have sort of themed pages for fossil insects, Cretaceous invertebrates from the Cretaceous World Project, and then fluorescent fossil beds. And there's a lot of information about just general information about the geology and things from fluorescent. And there's also some education modules. If there are any teachers out there that are looking for things for their classroom, there's some education modules on the fluorescent page. The other cool thing about iDigPaleo is you can go in and interact with the images in ways that you can't on traditional like portals like iDigBio and GBIF. So we have like measurement and annotation tools built in, so you can go and click on an image. You can set a measurement scale and then you could measure like the wingspan. So if you wanted to do something in a classroom, looking at like measuring body size or whatever, you can do that on iDigPaleo, which is super cool. And then lastly, I just want to plug our museum and field studies program here at University of Colorado. So if you're at all interested in working in museum collections, we have a master's program in museum and field studies. We also offer a certificate program if you just want to take a couple of classes and not enroll in the full master's program. And if you guys are interested in that at all, let me know. You get to work in the Paleo collections as a graduate student as part of your training, and then take a bunch of classes, and you have to do an internship. But it's a really cool hands-on program to get trained to basically do the job I do, which is manage museum collections. And then one more plug, if you're also interested in learning more about natural history collections in general, the professional organization that I belong to is the Society for the Preservation of Natural History Collections, which we lovingly call SPNHC. And SPNHC is $20 to join as a student member, so it's not super expensive. And they have some emerging professionals groups. There's a blog that is not super active at the moment. There's also a Facebook group, and they've been rebooting all the social media accounts for SPNHC. There's a new SPNHC Instagram account if you're interested in following SPNHC on there too. So it's a really great way to sort of meet more collections professionals and find, like, kind of just learn more about what collections are. And they've also been connecting a lot with natural history collections clubs, which are mostly undergraduate clubs on university campuses. So if you're a member of one of those clubs, there's opportunities to attend SPNHC meetings and do some professional development stuff. So with that, I just want to say thanks, and thanks for tuning in, and I'm happy to chat more about arthropods and collections.
Awesome. Thank you so much.
Sorry, that was kind of fast.
No, that was cool.
Okay.
Some of the fossils that you showed were, like, the detail in some of those insects is so cool.
Yeah, hang on. I have to go back. I'm gonna let me go back and share this one really quick, because I think it's just amazing. So let me find, like, this one is my favorite. Like, you can literally, like, this thing is, like, I don't know what the scale is on this one, because of course it's probably a centimeter. And think about how big a centimeter is. And, like, these hairs are so tiny. So tiny. Or, like, okay, this one, the scale on this is a millimeter. A millimeter. Like, they're so tiny, and this is preserved in the fossil record. Like, it's just amazing. So
cool.
I mean, like, working on vertebrate paleo stuff, we're so, we get so excited when we get, like, a tiny detail on a bone, and then you see something like that, and it's just, I don't know.
Yeah.
It's just,
whole
like,
world.
fossilization can, like, just happen in such cool ways, and you're just, you can learn so much more from these tiny insects. I'm geeking out just because I love seeing, like, just how cool they are, and it's not something you think about a lot when you're in vert paleo.
Yeah, and I think that's one of the things that kind of blew my mind when I came here. I didn't know a lot about insects or the fossil record of insects when I started working at CU, and I mean, it just blew my mind just going and opening drawers, and, like, everything you open is amazing. I didn't put it in the presentation, but we have a fossil tsetse fly here, and tsetse flies only live in sub-Saharan Africa today, but we had them here in Florissant like 35 million years ago.
Whoa.
And this thing is huge. Like, it's really big compared to modern ones. And you can see, like, the biting, sucking mouth parts on the end of the specimen. Like, it is just, it's mind-blowing. Yeah.
That's wild.
Yeah.
And I really love that, you and your museum are doing so much amazing work to get these specimens digitized and available to so many people out there, not just researchers, but the public too, as well, right?
Yeah, so that was one of the really big things on the fossil insect digitization grant was we really wanted to make sure that the collections were available not just to researchers. So some of you guys might be familiar with Paleo Portal, which was a maybe nobody's old enough to remember Paleo Portal. So that was an early attempt to bring museum collections to the public or to researchers. And part of Paleo Portal, there's a big education and outreach component of Paleo Portal. And so when we did the fossil insect grant, it was like, okay, this needs to be revamped in a way, to take advantage of modern web design and modern portal design. And like, if we were going to reboot Paleo Portal, like, what would it look like? And so one of the things we really wanted to make sure was, you didn't have to type anything in to start exploring the collections data. Like, I think that's a really big hurdle for people who want to, look at specimens. You can't just go on most of these portals and look at things. Like, you have to know a scientific name, or you have to know some piece of like technical information. And you also have to know how to navigate the portal, which is not always easy, even for researchers. It's not
Yeah.
always easy. And so portal design, this is what I'm talking about. Like, if you're interested in computer science, like front end user interface design is so important. And it's just something we're starting to think about now in the museum collections community. So like, if there's any budding computer scientists out there, like, there's so many projects to interface with fossils in different ways that doesn't involve just like going out and getting dirty and like collecting things. Like, you can do paleontology like sitting at a computer. Like, yeah.
I I'll agree because I've seen. I don't want to be mean, but I've seen some pretty unusable interfaces in the past. And it goes back to accessibility for audiences. And I think taking a step back, why do you think it's important that the public outside of museums have access to these kinds of collections?
Oh my gosh. Well, one, because they're amazing, and they're like part of our Earth's history. Like, this is part of everybody's history, right? And one, like, just locking them away behind cabinets isn't doing anybody any good. And I think there's so many people who are interested in collections, but that don't have access. So, like, what we have on display in our museum is such a small percentage of what we actually have in the collections. And we want to share those with people. And somebody might be interested in it from a research perspective. So, you might have somebody that works on fossil beetles or the evolution of beetles, or that wants to look at, how organisms react to climate change in the past. But then you might get somebody who is interested in it because they're an artist and they just want to draw it. Or you might get somebody who's interested in it because, hey, that was their grandma that collected that specimen. Or they're interested in Colorado history in the early 1900s, or they're interested in history of science and the people and the stories behind the collections. So there's so many different ways people can engage. And I think we haven't even like we don't know all the ways in which people want to engage with our collections, or the reasons why people want to look at our collections. Like, I mean, some of it's just like inherent beauty. Like, why do people like a T-Rex? Because it's cool. Why do I like the beetles with the little fuzzy butts? Because they're cool. I don't know.
Seconded.
So I think there's a lot of like reasons for why people want to engage with collections, and just removing as many barriers as we can. Like, that's just like that should just be the way we do things. I don't know. That's like a no-brainer to me.
I'm right behind you with that.
Yeah, same. All right. We have some great questions from our viewers. So let me go ahead and get into that. The first one is from Paula. In the Homotilius clusters, are there only adult specimens?
That's a good question. And I believe I did this research like 20 years ago, and if I'm remembering correctly, yes, there were only adult specimens. Have to think back it was a long time since I was an undergraduate. Um, but yes, I believe they were only adult specimens, and I did measure size on them. So we measured the body length on all of them, I think, too, and they were all adults. There weren't any juvenile trilobites present.
Awesome.
That's cool. A really quick shout out to Paula, because Paula will be joining us on Fossil
Yes.
Friday Chats in 2 weeks. So make sure you tune in then.
See you then. See you
Awesome.
then. Okay, this is going to be a question that's going to lead to another good question. So Bailey from the Alpha Museum is out of town, so we have Jared from the Alpha Museum fulfilling her sacred duty, which is to ask every person that we have on our show, what's your favorite fossil and why?
Oh my gosh, my favorite fossil. Okay, well, I kind of have two, and they're both kind of from our collections. So I love that fossil tsetse fly. It's just one of the coolest things, and I think the story behind it is so cool. And also, like the fact that it's so big, like modern tsetse flies are like just a few millimeters, like they're really tiny, and this thing we have is like a couple of centimeters, like it's really big. And just thinking about like that thing flying around in Colorado in the past, just the heebie-jeebies. I'm just like, oh my gosh. Oh gosh. And then I really love stuff from the Burgess Shale. Like,
Oh yeah.
Yeah.
I don't know. That was one of the things in grad school. Like, I got really into Burgess Shale, and I remember reading Wonderful Life by Stephen Jay Gould, and just like the story of discovery. So Anomalocaris is one of my favorite fossils as well, because I think it's so fascinating how, they found the body part and thought it was like a sea cucumber or something, and they found the mouth part and thought it was a jellyfish, and they found the like appendage things and thought they were shrimp, and like just the story of like the discovery of those things and then how they all got like pieced together as one organism. I think that's so cool. And I can't imagine like swimming around in the oceans with like this is what I do. Like I think about myself swimming around in the oceans.
We do it too. We all have that. It's like the fun imagination of like I always am like, what would it be like to be on the beach when a Desmostilian walks by? Would I try to ride that? Probably.
Yeah, exactly. Although I do love the exhibit in the Royal Tyrrell that kind of does exactly what you dream of. It kind of puts you underwater amidst all these invertebrates, and it's so cool.
Yeah, one of the things we like to have fun with here is doing sort of interpretive dance of our fossils. Like my Anomalocaris is like, I'm doing this. I'm like, who am I? Who am I? So we have a lot of these like sort of interpreting insects, or like what would this thing like an ammonite, like how would an ammonite have moved through the oceans, like how is it ejecting water out and it's moving backwards like this. So we have a lot of fun with interpretive dance. Yeah. And
that's fun. I'm gonna do that with like students as like as an opener one day. That'd be fun to do.
And it makes you think like, how was this thing that's this rock sitting on a shelf, like it kind of brings it to life, right? Like what was it like when it was alive? And I actually keep little plastic toys in most of our collection as well with things, because with invertebrates, we don't get soft parts preserved a lot. But they're really important sometimes for interpreting or like trying to understand what this thing looked like when it was alive. So a lot of times we have like the little, like I've got an ammonite that has like all the soft tissue preserved, and it lives on the shelf with the ammonite, the big ammonites, and it just makes it easier, I think, to kind of conceptually understand what these things would have looked like when they were alive.
Well, I think that's really important because, a lot of times there's some weird disconnection when we see a fossil, and it's not that we forget that it was alive, but it's just like we don't make that connection. If we look at animals today, their behaviors and everything they do are so complex, and we could never figure that out just from looking at the bones. It's the same with prehistoric animals, and I think the research that you had on trying to figure out what trilobites were doing when they were alive, it's so cool because it's a part of the story, and that's kind of where, I don't know if you'll agree with me, but that's like where kind of imagination plays an important role, you think?
Yeah, and it's this sort of fine line between like imagination and telling stories and then like, what can we actually say scientifically? And so, but I think that's the fun part, it's like, and there's still things today exhibiting these behaviors. So like roly-polies can roll up, like a trilobite could roll up, right? And so it's some kind of defensive behavior. And we see other arthropods doing these mass aggregations, just like we see, 450 million years ago in the fossil record. Like that blows my mind, like that we see these same kind of behaviors in these same like big groups of organisms. Like I think that's really cool. So
All right, this is another question from Alexa, one of our longtime young viewers. So it's got an answer about what your favorite fossil is, but what is your favorite trilobite specifically?
Ooh.
That's from
oh my
Alexa.
gosh. So maybe my favorite trilobite, and I should have put a picture of it in because I got to see the type of it in a museum collection once when I was on a tour, is a thing called Hypodichronotus. And trilobites have this plate on the ventral side underneath, which I didn't show you guys, called a hypostome. And Hypodichronotus has this really long, like forked hypostome that like runs almost the entire length of the body. So it probably couldn't enroll, which I think is really weird. And I just like to say Hypodichronotus.
It's a good name.
That's
Rolls off the tongue.
Yeah. I was also going back to the previous question though, or discussion about like behavior. One of my favorite Instagram accounts is the Monterey Bay Aquarium
Yeah.
account because I work with all these dead invertebrates, mostly marine invertebrates, although the insects are mostly terrestrial. But I just love watching their deep sea videos of how these things move and interact with other organisms on the seafloor. Like it's just one of my favorite accounts, and it really like brings to life for me like the collections that we have here that are immobile and have been dead for a very long time.
I completely agree. Like I sometimes when I'm at work, I have the Twitch live streams from the Monterey Bay Aquarium like on the side monitor, just because I love watching it and like
It's so
seeing
good.
the live animals.
Oh, yeah, put
It
that
kind
kelp
of
forest on.
yeah. It makes you. It's like it makes you feel good watching it, but it also like does stuff where like you're thinking like because you're all working with like dead animals all day, and you have to remind yourself that they were alive, they were doing stuff, weird stuff. Who knows?
Very weird stuff. Yeah, we just started looking at interactions in our collections. So things like, a fossil where we might have like a bivalve that has a bryozoan encrusting it, or a bivalve that has like a borehole from a gastropod in it. So to me, that's kind of cool too. It's like, again, bringing the collections to life. Like, what were these, how are these things interacting with each other when they were alive? And how can we tell that now from the fossil record? And sometimes we can, which is super cool.
Awesome. I can't wait till like somebody does like a Paleozoic Park or something, just so that we can see those like animated in CGI. Because the last time we saw stuff like that was probably Walking with Monsters, that old Discovery Channel documentary, which I love. But it would be nice to have an updated one.
But yeah.
So you should get on that, Gabe.
I think I'll see what I can do.
Where are the funders at?
Yeah. Just give us money, people. We'll make a Paleozoic park. It'll be great.
I mean, like, just watching like Anomalocaris come through and like try and like chase things and munch on things. Like I know there are some like cartoon reconstruction type things, but I want a big full like big budget movie.
Yeah. I'll work on that, and as soon as
Look into that,
I'll let
Gabe.
you know. We'll figure it out. We'll get it
Tap
done.
into the Hollywood connections.
All right, that's all of our questions for today.
All right. Well, thank you all so much for tuning in and asking those questions. Talia, we always end the show with a question for our guests. What piece of advice would you give to a future paleontologist who'd like to get into the field, or even for your case, what advice would you give to someone who wants to work in collections?
So I think the biggest thing for me is probably finding a good mentor. I feel like I got really lucky when I started as an undergrad at OU that I had a really awesome undergraduate advisor, and then there's a really awesome PhD student in his lab that just really like, you know, took me seriously and like introduced me to everything and like showed me how to do field work and how to do lab work and how to do science, like and just made me feel really welcome and part of the lab, even though I was this like, you know, freshman sophomore that didn't know anything. They were just like, oh well, you're part of the lab now, like, and you know, you're going to do all the things that we do, like you're a real scientist, you know. And it wasn't like I was marginalized or on the fringe. I always felt like part of the group. So I would say finding a mentor is really key. And it can be another graduate student. Like I learned so much from Lisa, like everything from like how to organize receipts in the truck to like, you know, how like literally like from the really simple things to the really big things. And then how to get into collections. There are lots of volunteer opportunities. So I would say look around for museums in your area. If you're in like K through 12, a lot of times there are classes, and that's how I got started, was just taking classes at my local museum. And then as you get older, there's more opportunities to volunteer in collections. A lot of places will have Vert Paleo prep opportunities, which is kind of how I got into it. And then, you know, when you're in college, like look around and see if you can work in a collection. You know, most museums have positions like that, or you can volunteer. We have a lot of undergraduate volunteers in our collection here. And then, yeah, you know, I went the PhD route and got the PhD and circled back into collections. But a lot of people are getting an undergrad in, you know, biology or geology and then doing a master's in museum studies now, which is a more common path than when I was in grad school. And there's some really good museum studies programs out there if you're interested in working in museums and doing collections work. So.
Awesome. Well, thank you for sharing the advice. And thank you so much for sharing your wonderful story with us today. We're really, really grateful to have you on the show. And we'll put all the links to the Fossil Institute Collaborative and everything in the description below so people can find that down there. And what's the best place for them to find more about you and the museum?
So probably the place we're the most active right now is on Instagram. So we are at CUMNH_invert paleo. And I try and post something every Fossil Friday. So sometimes it's like a random thing from our collection. Sometimes it's a specimen. And then the Fossil Insect Collaborative also has a Facebook page, but it's not very active. But if you want to go back through and look at cool pictures of fossil insects, we were posting a lot of publications and things like that. So if you're interested in reading more of the scientific literature, there's some of those on there. But that page is not super active right now. But yeah, probably CUMNH_invert paleo on Instagram.
Awesome.
Cool.
And
Thank you guys.
Oh, sorry. I was
go ahead.
Britt, what's happening this weekend again? What's the info?
Remember, everybody, the Western Science Center, where I work, and that helps host this show, is reopening tomorrow at 10 a.m. We will be going back to our normal hours, Tuesday through Sunday, being closed on Mondays. So we hope to see you all there. Again, we've been closed since last March, and we're very excited to premiere new exhibits and in what is, in essence, kind of a whole new museum. So if you're in the area, if you're in Southern California, we are in Hemet, and we hope you can join us.
All right. Well, we'll see you there tomorrow. And again, thank you so much, Talia, for joining us. We really, really appreciate it.
Well, thank you so much for having me. This was super fun.
All right. Well, thank you, everybody, for tuning in. As usual, if you like this and want to support programs like it at the Western Science Center and the ALF Museum, you can find links on how to do that in the description below. And as always, like and subscribe to our channel for more stories from the world of paleontology. Thanks, everybody. And we'll see you in 2 weeks. Right, Brittany? Yes, we'll see you in 2 weeks. Bye, everybody.